All right. I'm pretty sure at some point you must have had a lot of demoralizing, disgusting statements on how they claim in your family no one has ever excelled in mathematics. No one has ever excelled in sciences. It is okay, they have said all that. But I want to assure you today that that has nothing to do with your journey. It is okay if they fail, that is their own problems. Allow me tell you this today, that this is your journey. What you believe is what is to happen in your life. If you believe you can make it in math, you can make it in physics, you can make it in chemistry, geography, in history, and that is what will happen. What you believe is what you become. The principle of life. And indeed, if you believe that none of your family member can excel academically, and then it will happen. So I call upon all my students to actually start believing in yourself. You can make it. After all, very many people have made it in life. Why not you? You're welcome to yet another edition of OS e-learning platform. I hope you are all doing well. But before we embark on any discussion, let's have a prayer. Father, we thank you for yet another discussion of mathematics. Guide us, lead us. Whoever is to tap on this tutorial, let the overflow of your wisdom, knowledge and understanding prevail and take control in their lives. We believe that all we pray through the Son, Christ Jesus, who lives and reigns in heaven. We believe that all is possible. For the Muslims, all what we pray, we believe through the mighty name of Allah. Amen. Today we have a simple topic that we need to clear, and it's coming from the discipline mathematics with code 456/1, and particularly we teach this, or we discuss this in senior 3. However, since the tutorial is covering all students from senior 1 to senior 3, there is no harm for all of us to negotiate on this topic. A sample item is helping us to discuss the topic matrices under the theme data and probability. I think this is the first tutorial on matrices, and I pray we discuss and harmonize it. Now, there are some key things that I want us to first highlight under matrices. In other words, if it is a single matrix, then it's a matrix. Then, what is this matrix all about? Matrix is a row by column representation of data. Row by column representation of information. To those who are familiar with the software called Microsoft Excel, when you are representing information, we have the rows and columns. We have the rows and columns. And in real life, we represent data in rows and columns. rows and the column. For example, you are presenting your physics results from the measurements in the physics experiment. Now, the rows are these lines or spaces drawn, spaces created by having parallel lines drawn horizontally. Those are the rows. Those spaces created as a result of drawing lines parallel, those are the rows. These are rows. Then the columns are spaces drawn as a result of having parallel lines, while these parallel lines are drawn vertically. So these are the columns. So as you're representing information, for example, you have these square brackets to represent the information in a row by column. So for example, I have variable A, B, C. These can be values A, B, C, D. For example, I have variables 1, 2, 3, 4, this is maybe 5, and this is 6. Now, you can see that the rows for this first matrix, we have that is the first row, then another row is that one. Then the columns, we have this column, then we have other column there. So basically you can see we have the row by, we use a multiplication to represent by. There are how many rows? This is 1 and this is 2. So there are 2 rows by how many columns? This is 1 and this is 2 by 2. So the order of the matrix for this case will be a 2 by 2 matrix. 2 by 2 matrix. Let's check on the order of this. How many rows are you seeing here? We have one row, and then the second row is that one. Then how many columns? We have how many columns? We have this column here for 1 and 4 downwards. Another column is for 2 and 5 downwards. And then another column is for 3 and 6 downwards. So how many basically rows? This is 1, and then 2. So if you are using the concept of row by column representation of data, then for this case we shall have the order 2 by 3 by 3 matrix. So stating the order of a matrix, just count the rows, then by the columns, that will be the order. So this format of representing information or data is termed as matrix or matrices, if of course they are very many. Now, we read this information from we draft this or we extract this data from the information given, and then you give it a matrix order. Now, under matrix, we have very many operations, and that is the addition and subtraction, subtraction. Then we have multiplication, basically. Then for the case of division, we can divide the individual perimeter we can reduce the elements in the row and column matrix. You can reduce it by dividing it. For example, the whole matrix, you divide it by a half, then all the individual perimeters will be reduced. Let me use one example here for addition and subtraction. very fast before we get into the gist of the matter, real life situations where we apply. Taking an example that we have this matrix, I will take maybe a 2 by 2. Of course, under addition, this is 1, 2. The order of the matrix you're adding, or subtracting must be the same. If it is a 2 by 2, then should be a 2 by 2 matrix that is to be added or multiplied. So I just want to take this example, just this example. So how do we add? We can see that this is a 2 by 2. Then we are adding it plus a 2 by 2. So the order of the matrix for you to add must be the same, because we are going to add the individual corresponding elements in each matrix. So the corresponding elements, we can see that 1 in the first matrix corresponds with this 1 in the second matrix. So I'm going to have 1 plus 1, that 1 plus 1 will become a 2. Then we see that 2 is corresponding in the first matrix corresponds with 3 in the second matrix. So we shall add 2 plus 3, and that will be 5. Then if you look at 3, just add them, corresponds to 2. As in the share, the positions, okay, they appear in similar positions as far as the individual matrix is concerned. Now we get to realize that 3 plus 2 still gives me a 5. And then lastly, I have a 4. A 4 corresponds to 2. Then that will give us 6. That will give us 6. So still, this will give us a 2 by 2 matrix. So that's why when you're adding, you must have the same order. You must have the same order for you to come up with the correct response for matrix. Now when do we add? It depends on the scenario, of course. For example, in the first week, a student went for shopping. Then, of course, bought maybe some elements or items. For example, 2 books and 5 pencils. In the second week, or maybe 2 students, yes, 2 students went for the shopping. The first week, one bought 2 pencils and 5 exercise books, and then student B bought 3 pencils and 4 exercise books. In the second week, the same students went to the same market and bought again 1 pencil, 3, then 2 pencil, 2 exercise books. Then maybe the task requires you to ascertain the total number of books and pencils bought by the 2 students in the 2 weeks. So you get to realize that here we shall not multiply, instead we shall add. So the same thing with subtraction, you just subtract the corresponding elements in each matrix, depending on the scenario or the order. So that is basically addition and subtraction, and the order is they must be matrices of the same order. If it is a 2 by 2, it is okay. A 2 by 2, yes, 4 by 4, 3 by 3, but you can't subtract a 2 by 2 from a 1 by 2, because some elements won't get the corresponding unless they are 0. 2 by 2, but they have zeros as the values of the elements in that particular scenario. So addition, subtraction, done. Let's try the multiplication. Which rule do we follow while multiplying matrices? Now, if you check very well, even if it is of different order, let me start with the same order. For example, 2 by 2, 1, 1, 2. This is 4. Of course, this is 4. This is maybe 3. Then I'm multiplying it times 2 by 2. What do I do? Let me call this 1. I'm just using very small values. 2, 2, 3. How do we multiply? So the rule of multiplication is very simple. It is a row by column multiplication. So the elements in the row multiply with the elements in the column. Then after that you add. So it is a row by column rule. We shall use only this one example, and many examples. All the sample items will come in the next phase. So we shall multiply 1 times 1. So this one here times the one here, row by column. So the 1 times 1 will give me 1, plus the 2 times 2, and that will be 4. So that will help me get the first element in the first row or in the first column. So I have got it. Remember, the final result must be as per, or must contain the order of the leading matrix. Then to get the other element, I get to the second row. I'm still on first row times first column. I have got the first element. Then I've got the first element in the first row. Then still on first row, second column, I will get 1 times 2. That will give me 2. Then plus the 2 times 3. That will give me a 6. So this will give me the second element in that very first row. So I'm moving to the second row. So I will take control of the second as well row in the leading matrix. So that will still be row by column. So the row by column. So the second row, still I multiply it by the first column. And that will be 4 times 1. 4 times 1, basically that is 4. And then plus 3 times 3. And that will be 9. So I've got the first element in the second row of the final matrix. Then still the second row by the second column. So I get realized 4 times 2, that will be 8, plus 3 times 3, and that will be 9. So the row by column should be maintained here, and that will basically give me or give us, that is 5, that will be 13, that will be 8, and that will be 17. So the final results will therefore have a 2 by 2 matrix. It will have a 2 by 2 matrix. So that will be 5. This is 13. This is 17. that is 17. 8 plus 9, 17. Then 2 plus 2 is 2 plus 6, sorry, is 8. So you're going to realize that this is a 2 by 2 matrix, because the leading matrix here is a 2 by 2. So basically the leading matrix must have the same order, or the final result must have the same order, or must share the same order with the leading matrix. So that's how we multiply row by column. Let's sample this where the order is not the same. The order is not the same for the case of multiplication as well. For example, I have a 1 by 2 times a 2 by 2. Just use that example, see how we can negotiate with such a situation. For example, if I have a 1, that is maybe 1, sorry to use very small values just for easy multiplication, then times, we are multiplying, that is a one row and 2 columns. Then this is 1, maybe here is 2, here is 3, and here is 4. Okay, now row by column. Soon you will realize what we are trying to mean here. Row by column. Remember, our answer should be 2. If you check on this one, this is a 1 by 2 column, a 1 by 2 matrix. And then here, this is a 2 by 2. And our answer should be to the order of the leading matrix. And here the leading matrix is this one, a 1 by 2. So our final answer, we shall still maintain the row by column. The same, since it is one row, we'll multiply with the first column, we get the answer, and also multiply the same first row, or that very row, with the second column. So row by column, 1 times 1, that is 1, 1, plus 2 times 2, that will be 4. So I'm done with the first element in that very row. Then I still maintain row by column in the second column of the second matrix. So we shall still get 1 times 3. 1 times 3, the answer is 3, or the response is 3, plus, then times 4. 2 times 4 is 8. Then the final response will be 5, and then this side is 11. So you can see that the final response has the order of 1 row, this is 1 row, times, or by how many columns? This is 1 and 2. Okay, so this will be 1 by 2. So you can see that the final response has the same order with the leading matrix. So here, if the order is not the same, one thing I advise you is that the matrix with unequal order is the one we shall take as the leading matrix, because it's the one whose response is the one that will have the same response or the same order with its final response. So, and we are going to make use of this while getting maybe the amount of money required if someone went in I went to the supermarket and purchased some commodities as per the scenario. In the first week, second week, there is some kind of saving. So we shall just multiply the cost or the price, the amount, by the elements, and that will be a row by column. I repeat, a matrix to lead, let it be, just in case they are of different orders, then the leading matrix must not be of equal order. For example, 1 by 2, if you're multiplying it by 2 by 2, then 1 by 2 should lead. For example, 1 by 3, you're multiplying it by a 3 by 3, then 1 by 3 must lead. And the final response should be having the same order with the leading matrix. Then the case for division, I will just give you one for just reducing the elements, just in case the scenario needs you to reduce the element. Here we can't divide the whole matrix, as in what we shall do is just to reduce. For example, if I want to get a half of this matrix, this is a division, dividing a scalar. That is maybe 2, this is 4. Which order is this? This is, can I see someone guessing the order? If that is my matrix. Actually, division does not reduce the order of the matrix, but it just reduces the magnitude or the size of the element. So we shall get a half times 2. A half times 2, it's like 2 over 2, that is 1. We shall get still a half times this other 2, that will be 1. A half times 4, that will be 4, because like a half times 4 times 4. If you are multiplying, then of course this will be over 1. Then multiply 1 times 4, 1 times 4, that is 4. Then 2 times 1, that is 2. And then 2 by 2, 1 by 2 by 2, 2. So the final response here is 2. So we do the same with all the remaining elements. This one here is 8 over 2, and that is 4. So you can see that when I'm dividing a constant value, if I get the matrix divided by a constant value, let's say I have, then the matrix reduces, the magnitude of the matrix reduces, but the order remains. This is a 2 by 2. Here also it is a 2 by 2. So now, after having this knowledge, let's get into real life scenarios and practice the applications of matrices. We use this in business. We use this in very many ventures of life, in very many aspects of life, business, engineering, statistics, data collection, and very many aspects of life. So let's get into one sample scenario or two, then I will leave you with some trial items, and please make sure you try them out. Where you get challenges, inbox. The contacts are there. On your screen. I mean, everything's there. Reach me, please. We negotiate. I might not have everything as far as knowledge is concerned. Remember that no one is an island. We just learn every day. We borrow knowledge every day. Knowledge is like fire. You can't have it all. So at some point you have to share from a neighbor. So any addition, any subtraction, any compliment, I highly welcome all your opinion, because I believe I alone can't make this. I need you guys to be with me to contribute as well. Otherwise, let's continue with now the sample scenario. Let's continue with the sample scenario. Okay, this is the scenario now. Okay, so 3 schools from Gayaza region, 3 schools from Gayaza region want to participate in the national schools football. Sorry, let's first edit this. This should be went. So let's go through the scenario once again. 3 schools from Gayaza region went to participate in the National Schools Football Sports Gala held in Liantondo District Playground. The games started at 10 a.m. sharp, and each team played 6 games. So each team played 6 games in total. School A won 3 games, drew 2, and lost 1 game. School B won 4 games, meaning the draw is 0 because they lost 2 games. Remember, the total must be to 6. Here, even the total here is 6. Here also the total is 6, meaning drew nothing or 0. School C won 2 games, drew 4. Now, if you add 2 plus 4 is 6, meaning lost none. We continue. The game organizers award 3 points for a win, 1 point for a draw. Oh, this is very paramount. This is too important. 3 points for a win, 1 point for a draw, and no point, 0 for loss or a loss. They declared these schools the first 3 schools in order of their points. They obtained order of their points they obtained from the games. The first school was to receive the prize money of 16 million shillings, 16M. Then school in the second position was to receive 10M, 10 million, and 5 million shillings to the 5M to the third school. So the task here is decide the cash prize for each school. Well, I'm using this as a sample item to just help us exhaust the knowledge, extract the knowledge, or make use of the knowledge of matrix, basically multiplication. And in the upcoming scenarios, they will be more standard than this, because here basically there is no challenge, there is no problem. But my task here is I want us to get into the level of now learning how to extract data from the information given, then learn how to represent it on or in a matrix format, a row by column format. So besides that, let's first continue with this in the next slide. Then the upcoming scenarios will be having problems that they will require you to address. So basically here, let's just try to decide the cash prize for each school. In other words, let's just decide the positions of these schools as per their performance. If you look at the games they played, how they performed, and also how the results were awarded, we can do the multiplication of matrices and then come up with the winning school in the first position, followed by the second school and the third school, and correlate them or connect them to the awards So let's get into the responses for this particular matrix. So we get to realize that what I decided to use here is the extracting the matrix. I used the W for draw, W for win, draw, then lose. Then you have schools A, B, C, and from the extract we get to realize that we have school A having 3 wins, drew 2, and lost only 1. School B had 4 wins, drew nothing, lost 2, still making 6. School C won 2, drew 4, and lost nothing. Then the total still makes 6. So extracting it, I have 1, 2, 3. Those are 3 columns. Sorry, 3 rows. Beg your pardon. 1, 2, 3. 3 columns. So that is a 3 by 3 matrix for the results. Then for the price, still I can see that the points are given as per the win, the draw, and the loss. So you get to realize that win 3 points, you draw 1 point, you lose 0 point. As far as football is concerned, then this is 1, 2, 3. Those are 3 rows. Then basically we have 1 column. So that's why the order is 3 by 1 matrix award. Now basically to get to the cash prize, I just have to multiply these 2 matrices, and on multiplying I'm considering row by column for the first one, row by column for the second one, still row by column. Now for this case, the leading matrix is this one, and this will give us the final response. I remember telling you that the order of the leading matrix must be the same with the order of the final response after multiplication. So if I'm considering row by column, 2 times 3, 2 times 1, and then 1 times 0. That's why I'm getting this part for the first row. For the second row, maintaining the same column, I have 4 times 3, 0 times 1, then 2 times 0. 4 times 3, 0 times 1, 2 times 0. Then when I get into this last row, maintaining the same column, I get 2 times 3, 4 times 1, 0 times 0. So that is 2 times 3, 4 times 1, 0 times 0. And eventually on adding this plus that, it gives me 11. So this is 9, 2, 9 plus 2, you get 11. This is 12, 0, 0, you get 12. This is 6 plus 4, that is 10. So the final response, you can see that it has 3 by 1. And then my leading matrix is this one. Matrix with the unequal rows and column is the one I consider to be the leading while multiplying. So this one, you can also see it has 3 rows by 1 column. So it is the one that will give us the order of the final matrix. So keep that in your fingertips. The leading matrix, the order of the leading matrix is the same as the order of the final result after multiplication. So conclusively, we can see that school A, remember this is school A, this is school B, and then this school C. So you can compare 11, 12, and 10. Basically, therefore, school B in the in the first position with 12 points and won cash prize of 16M. Then school A, of course, in the second position with 11 points, winning a cash prize of 10M. And then school C in the third position, winning a cash prize of 5M. So basically, that is how we can get the cash prize for the results of this activity or participation. So that's how the schools performed, and that is how they were awarded. Now, in other scenarios, there must be a problem whereby maybe the committee members do not know how to ascertain the leading team such that they give award, and here comes your involvement as a mathematician to help them ascertain the correct information. So that's how we can do the multiplication, extraction of data, and then interpret. Okay, otherwise I hope this has been important for you, and I hope you make use of it in the next presentation. And the next presentation, I'm giving you trial items with an interest that you try them out and share the responses that you've discovered via WhatsApp. You can share them via the comment section. I will still review them. I will keep reviewing your comments, and I will keep responding to all of and each of you. Otherwise, thank you so much for this. Thank you so much for your time, dedicating your time to this tutorial is something that is very, very important to not only you, but also to me and to all our families, because by the end of the day, what we are learning here is not actually going to benefit you alone. It is benefiting the whole nation, the whole world. So thank you so much for your dedication, and I pray you keep the spirit, keep reading, keep researching, keep adding, keep discovering, and all shall get well with us. Otherwise, let's embark or hijack the sample trial item.
Umesomwa kwa mabaya, umetukwa majina mabaya, umeombewa mabaya, but remember God will never forsake you. Kalenda ya Mungu sio kama ya mwanadamu. If it's today, unaamka kupageko, nobody can stop the reggae. Kalenda ya Mungu sio kama ya mwanadamu. If it's today, unaamka kupageko, nobody can stop the reggae. Wadada watanisalimia kwa heshima, saluti afande. Walionidharau watanisalimia kwa heshima, saluti afande. Sikufi moyo ijapokuwa saa zingine ni ngumu, sikati tamaa bado, naweka imani bado nitafika. Kalenda ya Mungu sio kama ya mwanadamu. If it's today, unaamka kupageko, nobody can stop the reggae. Kalenda ya Mungu sio kama ya mwanadamu. If it's today, unaamka kupageko, nobody can stop the reggae. Walionidharau watanisalimia kwa heshima, saluti afande. Walionidharau watanisalimia kwa heshima, saluti afande. Sikufi moyo ijapokuwa saa zingine ni ngumu, sikati tamaa bado, naweka imani bado nitafika. Tetezi wangu hata uniseme mangapi, bado nasonga, sisikii kama meja, mimi sikii. Kalenda ya Mungu sio kama ya mwanadamu. If it's today, unaamka kopage ko, nobody can stop the reggae, reggae. Walionidharau watanisalimia kwa heshima, saluti afande. Walionidharau watanisalimia kwa heshima, saluti afande. Mtetezi wangu Yesu anaishi, hii hata uniseme mangapi.